They told you this couldn't be done, and they told you wrong. I'm Ray Myers. Welcome to Craft vs. Cruft. And today, with the first episode of 2024, I'm going to declare this is the year of formal methods, and I'm very excited to show you a refactoring kata, the Gilded Rose, done in a brand new way. I don't think this has ever been done, with proofs instead of tests to validate our refactoring. So I hope you enjoy this. You may have heard it said that tests can only show the presence of bugs and never their absence. And that's true. Many people take that to mean that you just in general can never show the absence of bugs. But if you look at the source of that quote, is from this write-up by Dijkstra on the reliability of programs. And if you're not familiar with Dijkstra, one of the most influential computer scientists, especially in the 60s and 70s, and he did say the quote that testing could only guarantee the presence of bugs and never their complete absence. But he wasn't saying you can't do that at all. He's saying you had to do things other than testing, that proofs are what make those full guarantees of the absence of a bug. And if you're a working programmer and you've ever used static type checking, you're familiar with this, whether you know it or not. You know that if a function returns a string, that it's not going to screw around and return an int. Like that has been proven by the process that the compiler uses to evaluate the program. It's not going to switch up on you at runtime. The type system, to whatever extent the language enforces it, is going to hold. So we already do have experience with some lightweight theorem proving going on in our software. Proofs go far beyond that. But at the time he was writing this, proofs about code were more something that you wrote down and you looked at it and you said, oh, this is correct. And then you hope that your implementation matches up with what's in your proof. Over the years, there's been a lot of progress. I'm going to show you a language today that I'm going to do Gilded Rose in. This language is called Dafny, and it is a very kind of programmer-friendly proof platform for a mix of imperative and functional programming styles. I'm using the Gilded Rose copied from and ported to Dafny from Emily Bache's repo. And so, you can follow along if you like. I've done a video on this before. I'll link it. You can look at my version, which emphasized, with IDE automation and reducing nesting levels. I did it to where there was never more than one nesting level in any given function. But there are a lot of other things you can emphasize with the exercise. This is great. As you see, they've done it in a ton of languages. We're going to do it in another today. As I say, this in a way that I think has never been done before, where we're doing the verification with a proof rather than with the automated tests. We still have automated tests. We still have the end-to-end, run all the items for 30 days. I'm not going to explain in great depth the nature of the requirements of this exercise. That's in other videos. But here they are, and we'll use this written spec as we go forward. But just to show you, this is the golden file. This is how the quality of the items should degrade over time. This is taken right out of their repo. I'm going to run my main method in Dafny, right? So it's going to make test will build Gilded Rose jar. Dafny builds to C# or Java or Python or Go and JavaScript. So quite a variety here available to you if you want to produce a verified component in your application. So we're going to build it in Java in this case, run it, and then save the output to out.txt. I'll delete it so we know that it's regenerating. And then it's going to diff them, and this diff will fail if they're different. So let me do all that. The verifier has passed, so it will compile. It is built, and then we've diffed the output. There's no differences. We can be reasonably confident because I just copied this over and modified a few bits of syntax, but also because the end-to-end golden file is identical, that this is an identical implementation. And indeed, you wouldn't expect, based on the language functionality, the same code to do anything different, except in the case of like an integer overflow. For instance, if we ran it so long that it did an integer overflow, Dafny will handle that differently because it does big nums by default. But other than that, this should behave pretty much the same. I recommend, if you're following along with me, that you start with the specification branch. It should be a little bit easier. I've just given you a little head start, although most of the behavior is still unspecified in this version. I have at least said that it will keep the quality in the valid bounds from one execution of its to the next. So I've put a required in assures. I've done a precondition and a postcondition here, that's the new syntax for you. But other than that, I haven't modified the implementation of this method at all. So again, this should run just the same. So let me walk you through the assurances that I've added. We're going to give on our item class this predicate. Predicate's just a Boolean function. So it's a check that this is valid. And so there's one special item that has special behavior with respect to being valid, having the quality in bounds, and it's the sulfurous sword. If it's the sulfurous item, then the quality should always be 80. Otherwise, it's not valid. If it's any other item, then the quality should be between 0 and 50 inclusive. Notice that we can chain comparisons in Dafny. All right, so that's just fine. Very, very simple predicate. And then from that, we have another predicate that we could give an array to, and it would say for every item in that array, for every index in that, within that array's bounds, then the item at that index is valid, right? About what you'd expect. So just introducing you to the way, for all is written. It's stating that something logically holds for all things that match this condition. So it's not exactly like going to iterate through all of them. It's going to just prove that property. That's a little subtle. Don't worry about it. It'll make sense later. We have our update items method, and the only refactoring I've done in advance is that I did a single extract. So we're just going to be operating on updating a single item. That'll simplify this a little. We're going to require as a precondition that all valid holds for this item. So every item in this array we're being passed has that valid quality that we specified a minute ago. And we ensure that after we call this, that's also true of all of them. So fine. And then there's another thing you wouldn't have seen here is modified. Like, in order for this to modify its contents, we have to declare that. So I think that's kind of an interesting thing about Dafny, is that you by default can't modify your arguments unless you declare that this is going to be modified here. If you've done work with immutable data structures, you maybe could see the benefit of doing that. But anyways, just going over all the items in the array and running update item on them, I'm using this same thing as a loop invariant. Like, after each iteration of this loop, it should still be true. It's true coming in, it's true after every iteration. If update item didn't ensure anything, that wouldn't hold, right? This would go red. We're not running anything, right? It's just going red at compile time because it can't prove that all valid is still true. I've called update item. Update item declares that it can modify the item. So now I don't know that the item is still valid, right? But because we have another pre and post condition on update item that it is going to be closed on item validity. If we want to get mathy, it has a precondition that if it comes in valid, it's going to leave valid. In that case, well, now that loop invariant holds. Now we know that that property is also true of the arrays that come through this. Okay, so we're getting used to thinking in pre and post conditions and what can be verified. And how did I verify this? Easy. I didn't need to. Dafny was smart enough to know that that property is going to be true for all of this code. So that was a pretty easy proof, right? It just sort of did it for us. That's awesome. So we're from the specification branch. I'm going to make a new branch for solution. And that's where I'm going to store the code here. So if you want to solve it, then start with the specification branch, or if you just want to look at my code, you can jump right there. But that's what we're going to create today, the solution branch. What we might do, or at least what I did in the version before, is I started looking for little incremental refactoring opportunities. But I'm going to take a different approach this time. I'm going to specify every part of this method's behavior that we care about. I'm just going to take the written specification and I'm going to translate it into a mechanically verified specification up here. And once we have that in place, anything we do to this code is fair game. Because for all the specified behavior, as long as it continues to pass, it will continue to be valid. So we're getting, arguably even greater assurances that we would get from a completely 100% test coverage without even running the code, because it is verifying it symbolically, not even for just the cases we have test cases for, but for anything in the specification. And we'll see what a specification actually is in this context. Hopefully I've sufficiently motivated this for us. It's going to be a little top heavy. We specify it, nothing changes, and then the floodgates are going to open at the end if we do all this right. So strap yourselves in. So what does it say here? Once the sell date has passed, quality degrades twice as fast. Quality of item is never negative. Aged brie increases in quality. So we got lots of little conditions of what happens. Right now, all we know is the quality is valid when it comes in, valid when it goes out. So for instance, we couldn't add item.quality equals 0 at the end of this. Right, that would fail the validity test, but only because of the sulfurous item. Other than that, if we said if is not sulfurous, and I'm just doing this to illustrate a point, right? And there's not a code change I want to make. If we said it, if it's not sulfurous, just reset it to 0 all the time. That would still pass because this is underspecified. It doesn't specify all the behavior that we care about. So let's specify more behavior. Start by specifying what each of these is supposed to do. We'll start with sulfurous maybe. So what is it supposed to do? It never decreases in quality. So this is in spirit what I want to do. If is sulfurous, then quality is unchanged, right? But sell in is decremented. All right, so what does that look like in a Dafny post condition? So it's a post condition, so we're going to say we're ensuring it. And this little if, it probably fits well with an implies arrow. There's a couple ways to notate that. But if sulfurous item.name, then that implies that the item.quality equals the old item.quality, so the one that was coming in. What else does it ensure? The item.sellin equals old item.sellin minus 1. Okay, so is that true? Does that pass? So I can see that it does not. Oh, without even running any tests, just the proofs don't hold. Oh, I see what's going on. Sellin was only decremented if it's not sulfurous. So again, both sellin and quality for this one maintain. So yeah, those are going to be just the same in the case of that one. So now we've specified the behavior for the sulfurous. Let's specify the behavior for another one. Aged brie increases in quality instead of decreases. And there's probably also, after it hits the sell by date, probably changes twice as fast. So let's say we'll need an is method for the other items. Let's just make them short for now. Is brie is backstage. And if something doesn't fall into any of these, there is kind of a default behavior, so we'll have to make sure we specify that as well. All right, so if is brie, what should happen? The quality is equal to the old quality plus 1. That's if we're not past the sell-in. And the old sell-in, it should be that minus 1, I suppose. So this is all if it's Brie and the old sell-in, let's say greater than 0 is probably what it's like. So let's see if this is what it's actually doing, right? If is Brie and the old sell-in days remaining is greater than 0, then we decrement sell-in days and we add 1 to the quality. That seems correct, but it's saying that it's not always. It's saying it's in this return path is the issue. I'm seeing actually the quality is being increased conditionally, right? Because it might be getting up to 50. It's only going to, if it's less than 50, add 1. So I feel like that may be the issue here. Another thing I can do here is copy a counter example. And this says it's experimental, so this probably isn't like the friendliest thing, but it'll say, hey, I've found a case where this doesn't work. So it's actually finding the counterexample to this condition that's been violated. And it's saying, okay, I've got aged Brie, and I've sent it in with quality 50. And, you know, a really high sell-in date, which probably isn't relevant to this. So, yeah, like the quality is supposed to increase there, but if it does, then it will contradict the valid range. So actually, there's a condition here that makes that not pass. And the counterexample did show us that. So how cool is that, right? Like, it didn't rely on us to, in our unit tests, find exactly where the edge cases were and test them. Like, it found the edge case for us. But we're going to have to update. In this case, the code's right. It's behaving correctly, but our specification isn't quite right. It's the old quality plus 1, but like within certain bounds. So we're going to need to bound this. So let's bound the quality. What does bounding the quality mean? We'll declare a function. And it's going to take in a quality of type int, and could also use type nat if we don't want to include negative numbers, but let's just operate in ints all throughout here for the sake of simplicity. So what is this? Well, it could be is less than 0, then 0, else if quality greater than 50, then 50, else quality. Simple, right? And that's going to not return a bool, it's going to return an int. Great. It's pretty well. The behavioral function is specified by its implementation, so we might not need to say that we're ensuring anything, but we could say, you know, hey, it's always going to be less than or equal to 0. Do a three-way comparison here. And you could also, by implementing max and min, have a more flexible way to do this, but whatever, it is just fine. Probably a good opportunity to extract a constant, but that's another refactoring exercise. So if we bound the quality there, yeah, now this passes. Now we have specified what Brie is going to do, at least what it's going to do when it's not past its sell-in date. What if it is past its sell-in date? Right? Actually going to be bound quality of the old quality plus 2 instead of 1. All right, does that pass? Yes. So we know, we don't guess, we know it is a mathematical theorem that the current implementation does follow this spec for all specified inputs. So now we have backstage passes, right? So these are a little more complicated than the other ones. This is where like having a specification checker is really handy, because it does increase in quality as sell-in value approaches, but it changes. When there are 10 days or less, it increases by 2. When there are 5 days or less, it increases by 3. And then the quality drops to 0 after the concert. So we have several different areas. And incidentally, like I'm collecting all the specs at the top of this method here. I get that they're kind of cluttered. You can also put these off in what are called lemmas. You can distribute these how you like. There are lots of different ways you can organize this if you prefer. But we'll just continue on like so. And if it is a backstage pass, then, and the old sell-in date, let's say greater than 10, I think is the base case, then the quality increases by 1. Right, and we've got the sell-in decreasing on all of these. We could probably remove that redundancy and just say anything but the sulfurous, subtracting 1 from the sell-in. And then we wouldn't need it here. That's equally well specified. So, backstage, yep, is it proving it? It's trying to run it. Sometimes this gets a little bogged down. It is kind of a computationally expensive process doing all this symbolic execution. All right, yeah. We're back. So this is a correct specification for the inputs we're saying for sell-in greater than 10 of the current implementation. So there was another one given. Could be less than or equal to 10, and we'll say it's what, greater than 5 is the other one, and then it needs to increase by 2 then. Okay, great. So, and there was one more where it's what, less than 5, greater than 1, greater than 0, probably greater than or equal to 1. Quality should go up by 3. Is that true? An accurate thing of what it's doing? All right, great. Let me just separate these: sulfurous, non-sulfurous, brie, backstage. We've shown all the special items, are specified here, but there are non-special items. They're just regular items. So let's make a simple, and these are, by the way, these are functions of bool. That's in Dafny. That's the same as a predicate is a function of bool. So we'll just do a little refactor. Be nice if we had an automated refactor for that. Maybe someday. Maybe I'll implement that. Yeah, we've got predicates, and then the reason I came up here was we want like an is normal, a way of saying, hey, it's not any of these things, it's some other item. And that is the case precisely if it is not brie, not sulfurous, not backstage. All right, looks like it needs to catch up here. This language server tends to, start multiple instances of the verifier at once. They're still tinkering with that, I think. But I just love these gutters, these green check marks that show up when it verifies different conditions and stuff. Really good feedback. If it's not any of these, then it's a normal item, and we haven't specified the behavior yet for a normal item. We might say that should be the first case we list. Doesn't really matter. It's just a style question. Ensures is normal item name implies that the quality is just going to always degrade by 1. The great thing about this is we can guess, and if it passes, we know we specified what the current implementation does, right? Oh, and maybe after it's by its sell date, it degrades twice as fast, right? So this is basically like normal is like brie in reverse. I remember now. So after the sell-in date, decreased by 2. Before the sell-in date, decreased by 1. Okay, I'll give it a second to run here. Great. So we're all green. These specifications are all definitely holding for any of the inputs they apply to for the current implementation. We've gotten over the hard part here, the hump. If there was any ambiguity in this, then we would have found it. if there was any deviation, and this is what you're going to run into in the real world. The existing implementation deviates from the spec you were given. Oftentimes it's the implementations that you need to pay more attention to. Oftentimes you need to not break the existing behavior, and the spec was just out of date. We would have found that by doing this without even updating or necessarily even looking at the code. Like this is showing us whether or not this is indeed, accurate. We now have a version of the spec we can inspect. We know that anything we do down here, as long as these continue to hold true, it's going to be accurate. So this is a really good commit point here. We could have committed, more incrementally as well. Specify current behavior. There are a couple of routes we could choose. It's saying we need to add a conjured item that degrades in quality twice as fast as normal items. So we could just go into like kind of a proof-driven development cycle and say, okay, we'll add, a specification for that, and then we'll modify this code to meet it. But we know we want to refactor this code, right? Let's introduce a new implementation, and let's showcase a feature of Dafny. There are functions and there are methods, but functions are a little more flexible and constrained as well. They can't make changes to the environment or to their arguments, but they can be used in these proofs, right? So you can't call a method in the middle of a post condition like this. But as you can see, I'm calling functions in the middle of these. So basically, if I made a new implementation of this, I could say, hey, ensure that this method behaves identically to this other implementation. So let's see what that looks like, right? So let's make a function called update. Let's do the sell-in first. That's a little easier. What's it return? Probably an int, say 0. We want to say that the new sell-in ensures item sell-in equals update sell-in of item, which is not going to be true yet, right? Of at least update sell-in of the old item. I think I'm doing that right. So this will say no, because obviously it updates some of the time, and we're just setting it to 0 all the time. So let's just step through these one by one, right? So let's say, is this true for is normal? And we're just going to do this kind of a scaffolding so we can step through the cases. All right, so this is kind of a quirk of Dafny, because this is an object, I think, and still working through my copy of program proofs, so not sure if I'm doing this in the easiest way, but I'm just gonna pass in the components of it so I can do the old notation here. And so the new sell-in value does not depend on the quality, so I think we just pass in name and old sell-in. Okay, so what does the sell-in value do? Well, we've established on a normal item that it just goes down every turn, right? As long as it's not sulfurous, it just goes down every day. So that's fine. Sell-in -1 is what we're going to return, at least for normal items. All right, prover got a little jammed up there, but nonetheless, yeah. So for quote unquote normal items, right, this should work. And indeed, I think it's sulfurous is the only thing this shouldn't work for. So let's see if we can expand this spec a little bit and see if this is true for any non-sulfurous item. Yes, it is passed. So now what about the sulfurous case? Well, the sulfurous case is just that sell-in never updates. So this should fail now. Like, yeah, this won't be equivalent to the current implementation, but it will with just a quick modification, right? We just need to put this check. If it's sulfurous, then we just return the old sell-in, else we decrement it. So is that equivalent to the existing implementation? Ka-chunk, ka-chunk. All right, it's passed. we have this selin updated. Right now, in theory, we should be able to take out the part that updates the selin and replace it with our other implementation. But let's do the part that updates the quality. So we're going to have a similar thing to this, but it's going to be update quality. It takes name, selin, and quality. And again, we'll start at just returning quality. That won't pass right away. But might for sulfurous, though. We'll start it there. So is sulfurous, should be able to write this fairly easily now. It should be clear to you, the spec I'm about to make. Is sulfurous implies update quality of the, I guess it doesn't need to be the old name because we've established the old name is the same as the new name. And then old item selin, and then old item quality equals item quality. Yeah, we give is sulfurous the name, and that should work. Let's see how that does for us. So what I'm thinking here is that I'm just returning the old quality here, and the sulfurous doesn't change in quality, so that should be just fine. Great. So that passes. What are the other cases? So it's maybe it's a normal item, right? And so that is what we want to do if is sulfurous name. And unclear what structure this should take. You know, maybe if the cell in greater than 0, then quality -1, else quality -2. I mean, that's going to be true for some of these. We're going to have to put in more cases. So let's see if this is true for not just sulfurous, but also for is normal. This thinks maybe the syntax is wrong. That didn't take, so let's see if this is right. If it's sulfurous, then return it unchanged. Otherwise, if the cell in is greater than 0, it should be, we return quality. That's not true. We return the bound quality because it's gotta, again, not fall below 0. So actually, that was a good catch. It did catch an actual error in our implementation. So if we do this, then now it should pass for all specified cases. Indeed it does. Great. So we've got it working for sulfurous and normal. So let's make sure the new implementation holds up for Brie, which is just the inverse of normal. And it's not going to now. We're going to have to do something. Tons of ways we could organize this. Let's just try getting a degrade rate just based on the selin data. I think that'll work for several of the cases. I need to specify a type on that. Else if it's Brie cell in. And then let's have, you know, maybe a little variable to say expired so we don't have to keep comparing cell in. So this will be a little clearer. In that case, then the degrade rate's actually increasing in quality. If it's not expired, then -2, else and let's ignore the backstage pass case. Expired is 2. That's 2 that is degrading by else 1. So we just want to subtract the degrade rate given the name and the cell in. We already account for sulfurous up here, so we should be able to just say we're doing quality minus the degrade rate and bounding it and return that. Does this do all the cases? But saying it fails for sulfurous actually, which is a little surprising, but we'll see. Bound quality for, yeah, you can't do bound quality on sulfurous, unfortunately. So, you know, we could update that to take a name, or we could just, you know, handle it in a base case here. Just flipping a coin here. I'm gonna just simplify the rest of this. And all right. Incidentally, I know some implementations of Gilded rows like pull out a class hierarchy, and there's virtues to that approach. We're not so much trying to reach the optimal code organization. We're just trying to show that whatever our new solution is, we can replace the old one with high confidence. So let's just give this another to go to, like degrade rate backstage, and say, you know, if is backstage, because this implementation is just so different, then we're going to return degrade rate backstage, make all these else's. If cell in less than or equal to 0, then I think we recall the degrade rate actually, well, the quality just drops to 0 in that case. Yeah, I kind of paint myself into a corner there because I need the quality. So let's handle that out here, and let's make that like an update quality version. Update quality backstage. So we know that it's a backstage pass at this point. What do we know about that? If cell in is less than or equal to 0, then the quality, it should just be 0. Else if cell in greater than or equal to 10, I want to say, then what the quality is just going up by 1. Let's see what we specified down here. So that's the quality greater than 10. And what it's like, if it's between 5 and 10, inclusive in the way specified, then it's quality plus 2, else if it's less than or equal to 5, in which case we know it's not 0, that'll be 3. Okay, so this should be equivalent. Fill in my ifs there. All right, so if it's backstage, update quality with the backstage implementation. We have the ones that degrade. Okay, it wants me to make it more demonstrably exhaustive here. All right, so yes, now it is true for normal, it's true for Brie, it should be true for backstage as well. Let's make sure the update quality method is now implementing backstage the same way. Okay, and it is not. Isn't it cool that we can find that out? All right, so let's see if we the counter example again gives us any Hint, it's going to be a backstage pass. It's going to have quality 48 and sell into, so this is a bounding issue. Yeah, we didn't do the bounding yet. We forgot the bounding. These proofs are really helping us. Let's just say this is the unbounded version. And I'm going to wrap a bound around it. That'll be the little shortcut here. So let's see how that does. All right, great. So we've got normal, brie, backstage, sulfurous. So I claim that this should now be equivalent in all cases. So we have an implementation of sell-in, of update sell-in, and an implementation of update quality that, like, albeit it's not, perfectly refactored, is much better than this, the original, and is like provably equivalent for all cases that are specified, where we've got a valid item coming in. That's a little good commit point. I'm gonna do a commit called add equivalent functional implementation. That was all led up to this payoff. So if you stuck around this far, that's awesome. Now that we've said this is definitely equivalent to the old one, we can simply replace it. We can say that item, let's say this was our old sell-in and our old quality. Let's say sell-in equal to update sell-in of what item name and item, well, quality is not needed for that one, and item name, item sell-in, and item quality. I'll go into update quality, assign it to the right field. We don't need to save them both. We just need to save sell-in so we can pass it in unmodified to the second one. Swap that implementation out, and boom, we've just retired the original code, and we know that the new one, for all specified cases, behaves identically. And I'm going to do a commit point, replace with functional implementation. Again, this whole time, we never ran the code. We only ran the compiler and the verifier, right? So it was only executing symbolically on like abstract things that try to cover every possible input. We never actually did a traditional execution of this program. Let's do one now. Make tests. We build, we test, we run over the same test against our golden file, and yes, our output is identical to the golden file because of course it is, right? So there you have it. There's a bit of a learning curve here, obviously, even just with the syntax that you've seen, and we never actually had to get into like proving with loop invariants or anything else. These properties, they were all very simple, trivial properties, as is often the case, that the prover was able to just kind of eat for breakfast. But nonetheless, like look at this powerful tool we have at our disposal, and I'm curious to see how other people think that we might be able to use this on legacy code. But I hope you've enjoyed this exploration and proof-driven refactoring, and with patience, the most tangled cord may be undone. Thank you.